Hello everyone, my name is Shilpa and today I'm here to give presentation that will be covering some few information about noise. So let's get started. So you can see some of the topics on your screen that I'll be explaining in this video, that are noise figure, SNR, RSSI, noise factor, noise equivalent bandwidth, white noise, narrowband noise, and noise temperature. So before getting to the noise figure, I want to brief out what is noise. So in any communication system, during the transmission of signal or while receiving the signal, some unwanted signals gets introduced into the communication, making it unpleasant for the receiver and questioning of the communication. Such a disturbance is called noise. So simply, the noise is a signal which interferes with the original message signal and corrupts the parameter of the message signal. So noise is of two types, the external and the internal noise. External noise is produced by the external sources which may occur in the medium or channel of communication usually, and the internal noise is usually the interruption that is being created in the system only. So getting to the noise figure that is denoted by NF and noise factor that is denoted by F are measures of degradation of the signal to noise ratio SNR caused by the components in a single chain. It is a number by which the performance of an amplifier or a radio receiver can be specified, which lower value indicating better performance. The noise factor is defined as the ratio of output noise power of a device to the portion thereof attributable to thermal noise in the input termination at standard noise temperature T0, usually 290 Kelvin. The noise factor is thus the ratio of the actual output noise to that which would remain if the device itself did not introduce noise. So simply we can say that it is the ratio of input SNR to the output SNR, that is signal to noise ratio. The noise figure is simply noise factor expressed in decibels. Okay, coming next to RSSI and SNR. The RF is everywhere, coming from earth, heat, space, human activities. The amount of unwanted RF is called the noise, the background noise, and when we subtract the noise level from RSSI, it gives us the signal to noise ratio, that is SNR. Okay, so the next is noise factor F and the noise figure NF, which will make you clear about these two, F and NF. Then now the figures are of merits used to indicate how much the SNR deteriorates as a signal passes through a circuit, and the noise factor is simply a ratio of input SNR to output SNR. As you can see on your screen, F is equals to input SNR upon output SNR. So the next is noise equivalent bandwidth. Equivalent noise bandwidth of a brick wall filter which produces some integrated noise power as that of an actual filter. In other words, it is the frequency of brick wall filter at which both filters, the real filter and the brick wall filter, have some integrated noise power. This is also referred to a noise bandwidth or effective noise bandwidth. The equivalent noise bandwidth may be abbreviated as ENBW or NBW and may also be named as noise equivalent bandwidth. Note that the ENBW is the equation above is normalized both for the maximum value of H as well as for the internal spannel YW by length. Thus, for example, an all-pass filter with a gain 1 should have ENW is equals to 1 because it is closer to the brick wall filter. So the equation which is displayed on your screen, the equation above measures the amount of noise power that the system passes. The square on H implies power, C is decibel, the term noise, and makes sense as we are concerned with the whole frequency spectrum. ENBW thus measures the noise power that is accumulated in the magnitude response of the filter. So next we have is white noise. The signal processing white noise is a random signal having equal intensity at different frequencies, giving it a constant power spectral density. The term is used with this or similar meaning in many scientific and technical disciplines including physics, telecommunication, and statistical forecasting. White noise refers to a statistical model for signals and signal sources rather than to any specific signal. White noise draws its name from white light. Although light that appears white generally does not have a flat power spectral density over the visible band. So in simple, we can say the noise is generated due to the thermal motion, and the motion is known as Brownian motion of electrons inside the resistor. This noise is zero at absolute 0 degree Kelvin and generated when temperature rises, also called thermal noise, also called Johnson noise, who invented it. The thermal noise, also referred as white noise, since it has uniform spectral density. Okay, so next we have is a narrowband noise. So in most communication systems, we are often dealing with band pass filtering of the signals. Wideband noise will be shaped into band limited noise if the bandwidth of the band limited noise is actually small compared to the carrier frequency. We refer this as narrowband noise. So you can see a figure on your screen that shows how the generated narrowband noise from wideband noise. So generation of narrowband noise, we can derive the power spectral density and the autocorrelation of the narrowband noise and use them to analyze the performance of linear systems.